Hello, I am Gitika. The question is, I have 10 weights of integral values ranging from 1 to 10 kg. Some of the weights have been placed at the positions, while at some places the values have been replaced by some alphabets. They are placed in the balance shown above, such that the whole system is balanced. For this system, the basic rule states that a weight A at a point P units from the point of suspension effectively acts as a weight of PA kg. For example, consider the adjacent figure. Both the figures are drawn to scale. The equation of balance will be written as 2A plus B is equal to 2C because both weights A and C are at a distance of 2 units from the points of suspension. Apart from this, in case a balanced system or a part of it is against another system to balance the same, the total weight present and on the balanced system will be considered at its total weight. That is, in the above given example, we can balance the system with the following values: A is equal to 3, B is equal to 4 and C is equal to 5. Thus, the above equation will be satisfied. 2 into 3 plus 4 is equal to 2 into 5. But if this system is used as a part of another system, then its total weight from the point of suspension will always be considered as 3 plus 4 plus 5 is equal to 12 and not 20 as observed from the equation. What is value of A? Solution. From the given balance, we can see that one of the equation will be twice 3 into C plus D as formed from this point of suspension. Therefore, we can write 2 into 3 plus C is equal to D. This implies D minus C is equal to 6. Now, we know that weights 1, 3, 8 and 9 have been already used. Value of D can be 7, 8, 9 and 10. Let D is equal to 7. Therefore, C will be equal to 1, which is not possible as weight 1 is already used. Let D is equal to 8. Therefore, C is equal to 2. But weight 8 has been already used, therefore not possible. Let D is equal to 9. Therefore, C is equal to 3, which is again not possible as weight 3 is already used. The only solution remains D is equal to 10, therefore C is equal to 4. Now, weight D and C are found as 10 and 4 respectively. Taking the second equation of balance from the diagram, we see that thrice of A into twice of B is equal to twice of 9. That is, this can be written as thrice of A plus twice of B is equal to twice of 9, which implies as 3A plus 2B is equal to 18. Weights that have been used now are 1, 3, 4, 8, 9 and 10. The only possible solution of this equation is A is equal to 2 and B is equal to 6. The other two weights can easily be found as E is equal to 7 and F is equal to 5. Therefore, answer from the option is option number 3. Thank you. Hello, I am Gitika. The question is, what is the value of F? Solution. As we have seen in the earlier question, value of f is 5. Therefore, from options, answer is option number 1. Thank you. Hello, I am Gitika. The question is, if the weights B and E are swept, which side will be balance tip? Solution. Weight B has an integral value of 6 and weight E has an integral value of 7. If the weights B and E are swept, the weight on the left will increase and the weight on the right will decrease. Hence, the balance will tip towards left. Therefore, answer is option 2. Thank you. Hello, I am Gitika. The question is, the 7 digits from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 are represented by a different letter in the adjoining figure. If A into B into C is equal to B into G into E is equal to D into E into F, then what does G represents? Solution. In the given figure, which have A, B, C, D, E, F, G as integral values from 0 to 9, we see that for 3 products to be equal, none of the letters can have the numbers 0, 5 and 7. Therefore, the remaining letters are 1, 2, 3, 4, 6, 8 and 9. The maximum possible product is 9 into 8 into 1, and any higher number like 9 into 8 into 2 is not possible. Therefore, arranging these digits or forming a product of 72, we can see that in this case 9 into 8 into 1 is equal to 9 into 2 into 4 is equal to 3 into 4 into 6, that is 72. Therefore, answer is option 4. Thank you.